오늘은 제가 아주 재밌는 영화를 준비했어요. 그래서 영화 관람이 메인일 거예요. 30분 정도 영화 관람 할 텐데, 그 이전에 제가 간단히 좀 이번엔 오늘부터 무슨 토픽이죠? 표상과 크리에이티비티예요. 거기에 관련돼서 제가 좀 설명을 하고 재밌는 영화를 보여줄게요. 그 플랫랜드라는 영화를 본 사람 있어요, 혹시? 플랫랜드라는 영화를 볼 텐데요. 이 사람의 백그라운드를 제가 간단히 설명드리면은 애들이 너무 수학을 재미없어 하는 거예요. 어떻게 그럼 수학을 좀 재밌게 구성해 볼까 해서 이 영화를 만들었어요. 이게 1960년도인가 영화가 나온 거예요. 그래서 차원에 대한 영화예요. 그래서 여러분들이 한번 이 영화를 보고 그 시각화의 파워, 무슨 말이죠? The power of visualization에 대해서 느껴보기를 원해서 제가 이 영화를 한번 같이 보면 좋을 것 같아서 준비를 했어요. 자, anyway, take a look at the details course schedule. We have done through what? 10 weeks, right? Storytelling creativity, manipulative creativity, and from this week, we are going to cover representation creativity. And week 13 and through 15, your group presentation, and in the final week, you are going to do a survey. Anyway, from your perspective, I emphasize this is, three senses: hearing, touch, and sight. From now, we are going to focus on how to visualize mathematics, okay, by using a different kind of representation. So, epistemology and representation. One of the important things related to representation, you should realize students need to create formal and informal representation to communicate mathematical idea, right? Make sense to you? Usually in elementary school, many students, create their own representation. For instance, in informal representation, right? So that is one of the important process in learning mathematics. Second one, you need to translate from one representation to another one, right? For instance, in algebra, you're supposed to use algebraic representation to understand what? Geometric representation, right? You need to emphasize the relationship between algebraic and geometric representation. Finally, in terms of using representation, by using representation, you should model and interpret some phenomena related to mathematics. For instance, STEAM. What is STEAM? Science, technology. What is E? Engineering, art, mathematics, right? So there are a lot of different kind of model which can be interpreted by using mathematics. So can you see the different level of understanding in terms of understanding representation, creating representation, and translating representation, and using representation to model and interpret phenomena related to mathematics. I'm sorry that this is I don't know why or what happened. Anyway, creating representation, there are a lot of different kinds of representation. For instance, language, figure, drawing, diagram, chart, graph, symbol, right? Do you agree with that? In learning mathematics, this kind of representation is so important to deeply understand mathematical idea. Also, a representation or image of mathematical idea, right? Do you agree with that? For instance, one is not just a simple concept, right? One can be represented, with many mathematical ideas, right? One apple, one banana, one cups, right? one pen, likewise. Also, the common mathematical nature of different situation. Do you agree with that? Right? For instance, some representation can be used to model different kind of situation, right, in real life. Also, representation makes mathematical idea more concrete and available for reflection. It is obvious, right? If we would not use mathematical representation, how can we organize our thinking? Do you agree with that? Right? This is the power of representation in learning mathematics. As I said, you can organize your thinking by using mathematical representation. Otherwise, it's not possible, right, to organize your thinking. Finally, in elementary school, students need to translate verbal information into symbolic expression and equation. Any question? Do you understand what is the meaning of creating representation? What is the next level then? After creating representation, you should translate, right? Representation between two of them. By using this kind of translation, conceptual understanding can be enhanced. Also, you should emphasize different way of explaining mathematical idea, right? Algebra representation emphasize some aspect of mathematical idea, right? In contrast, geometric representation emphasize what? Other aspect of the same mathematical idea. So therefore, you should think about different way of explaining mathematical idea, the same mathematical idea, right? Do you agree with that? For instance, think about just a simple example, right? A plus bi plus c plus di, right? Two complex number. This is algebraic representation, right? It looks like just addition. However, in geometric representation, as you can see, a plus bi, c plus di, you can represent geometrically, right? But this is obviously, the same mathematical idea can be, right, expressed by using different way, right? Obviously, in one representation, there are advantage and disadvantage. Do you agree with that? Just think about, this is conceptually very deep. Especially if you're going to study mathematics education further, you need to think about this issue. Because in one representation, there are advantages. However, right, there are some disadvantages only using one representation. Therefore, we strongly recommend our students to use multiple representation instead of using just only one representation. I think this is my perspective, by the way. In addition to different way of explaining mathematical idea, different representation may have some synergic effect on conceptual understanding and creativity through translation. Do you agree with that? I mean, for instance, there is one mathematical idea. But if you do know one representation, you may have some power, right? In terms of, mathematical idea. But if you do know two representation in only one mathematical idea, math idea and one representation, two representation, and three representation. In this case, if you do know 1, 2, 3 representation, I think there is some synergic effect in terms of developing mathematical idea, right? Because, mathematically, maybe the one who have more, multiple, understand multiple representation, they may think, in depth, the same mathematical idea compared to others who know only one or two representation. That's what I'm trying to say, synergistic effects. And finally, using representation to model and interpret the phenomenon. Do you remember the modeling lectures, which is conducted by Yang-Jin Kim, Konkuk University? Maybe most of you maybe slept, right, during the lectures, because it's kind of, too difficult, I think, from my perspective. I asked, him, to address, his, main idea easily, but, it may not difficult. But actually, anyway, so think about, modeling process, by using representation, probably it's going to be doing mathematics rather than just knowing mathematics. That's why it is worthwhile, to model, phenomena by using representation. Also, it's going to be opportunity, right, for students to understand the power and beauty of visualization by using this process. Use of visualization in student personal life and in workplace and in further study. Anyway, this is just additional comment about use of representation for visualization. However, one thing you should remember, there is a limitation of visualization. What do you think? This length should be the same as this one, right? This one should be the same as this one, right? This one should be the same as this one. If you're going to continue this process, what happens? Two lengths seems equal to one length, right? 1 plus 1 equal to what? Seems like 1. 2 equal to 1? Actually not. So think about limitation of visualization, right? This is a good example. You need to be careful in terms of using visualization in learning mathematics. And you think about this issue.